Shall we start?
Yes, please.
Okay. So good afternoon and very warm welcome to everyone. I'm Dr. Gulab Chand. I'm so pleased to be with you today and to have the chance to introduce our resource person, Dr. Kamal Kumar Chaudhary. Dr. Chaudhary is an assistant professor at Department of Humanities and Social Sciences, Indian Institute of Technology, Ropar. Dr. Chaudhary completed his PhD from Max Planck Institute of Human Cognitive and Brain Sciences, Leipzig, University of Leipzig, Germany. Before joining IIT Ropar, he worked as a visiting faculty at the Center for Behavioral and Cognitive Science, CBCS, University of Allahabad, India. Dr. Chaudhary is a linguist and cognitive scientist and works in the area of neurophysiology of language comprehension. Currently, his research focuses on ergative languages. Uh, Dr. Chaudhary has published several research papers in reputed journals. So, Dr. Chaudhary, now over to you. And let me announce one more thing. Please write if you have any questions regarding the lecture. Please write your questions in the chat box after the talk. Sir, over to you.
Yeah, I'll just share the screen then. I'll just start. Are my slides visible, Gulab?
Yeah.
Okay. So good afternoon, everybody. I would like to, before I begin my talk, I would like to thank Professor Yuan Singh and Dr. Gulab Chand for organizing this event. And I would also like to add some disclaimer before we begin this talk. So as you see that this talk is in the series of language and cognition, and I'm going to speak today on electrophysiology of language comprehension, because this is a vast field, and nowadays we are doing lots of online talks. So there has been several goals to like how we are going about it. So I will precisely tell that what we are going to do in this talk. But before that, it is important to know that I was told that the goal is several, and the way now cognitive science and neuroscience is coming up in our country, it has started the work in this domain I'm going to present has not happened much. So many times the audience is not familiar with. So I will focus on this topic and try to show that what electrophysiological data can give us so that we can have a better understanding of the phenomena, so what it has added to it. So this is a kind of generic in nature. Unfortunately, we do not have the interactive session to have your questions or something. I don't know like how things are going, but if you can write in between also, so I'll be happy to answer that. But towards the end, we will take all the questions, and those of you who are looking for collaborations, because people are from different backgrounds. So I hope that the message is communicated. And so we see this talk in that spirit. So I'm not going to touch upon many issues. So the way I have planned is that the talk is that I will start briefly talking about general introduction with language cognition, and then talk a bit about language comprehension system and what we are doing there. And then I will briefly mention about the tools we have in the market to investigate. We are calling because we are working on language and brain, but in general to brain. That's what has brought the field like cognitive science and cognitive neuroscience. And then I will tell a bit about electrophysiology of language and discuss some very preliminary data from our lab with simple experiments, which we believe that should be comprehensible to anybody, any audience who is watching this video from any background. So it is not a specific for linguist or cognitive scientist, but a general introductions. As we know, in general, language and cognition, as we know, is a very vast field, and we have dealt with several questions. There are many unanswered questions like, but the basic idea has been to see that how language in general impact cognition. We all are familiar with this debate of how language influences thinking or thought, what precedes or not. Just add to something like today, and this is also of my domain where I work a bit. Today I'm not talking about that. Like we have started asking questions like, is language similar to the other cognitive systems? Let us say something like thinking, memory, and something like that. But today, for today, we are focusing more on how do we comprehend language. Basic idea is that when I'm talking to you, how is your brain understanding what I'm saying, or how do I understand? I will talk a bit on that. But let us see that what has happened in last couple of decades. What has happened is that we have started getting sophisticated neurocognitive methods to study normal brain, and which has also, given birth to subjects like cognitive neuroscience, cognitive science, where people from different background, different expertise are working together. And electrophysiological method has been extensively used for various kind of cognitive processes. It's not only for language, but other kind of cognitive processes like thinking, memory, attention. And of course, our goal, one of the goals we are not doing today, is also to understand how language interacts with this system, right? But today, as I said, I am focused trying to understand that how can we use this system to understand and what knowledge it can give us about what we are not able to get earlier about the language comprehension system, right? So, but of course, it will be important to know what we mean when we talk about language comprehension system. So here I am trying to make it precisely the point we are looking at is like in day-to-day life, when we are talking to one another, how is it that our brain processes all the linguistic information so fast, like how we process. Of course, we all know that it means that we are processing all kind of linguistic information, that is like phonological, morphological, syntactic, semantic, pragmatic information in a fraction of a second. We also know that some cases, unfortunate cases where language impairment is the case, this is not the case exactly as smooth as like this for us, because we are blessed with this system. We do not have any problem, but these are the things which is problematic. So people say that in 1 second, at least we produce around 3 to 4 words. At the same time, you are processing 3 to 4 words. It means in a fraction of seconds, we are able to compute all this kind of information, and processing never fails, right? We laugh at jokes, and you know that happens. There are very few points where I see that people agree in like still the answers we have, but still there are a couple of points where we can say that people say that, no, this is for sure, we can say this happens in language comprehension. And one such thing is that people believe that language comprehension is incremental in nature. That is, as and when we process the word, parser makes some kind of interpretation, analyze it, and then process further. So it's not like that it is waiting for the end of the sentence or something. One word you are processing, you have some kind of interpretation. That's why one can ask that what happens in the case of ambiguity. In ambiguous structure also, people will do that some kind of decision parser will take and go ahead. So this is the point. So point is that incremental. The questions are many, but as I said, I'll come to my point, that how these information itself get organized, phonological, morphological, these things. I'm not talking. So here I'm telling this is what we mean by language comprehension when I'm saying how you interpret this information. To understand better, let us take these 2 sentences from English, which we use always in the class. You see, the man chased the dog and the dog chased the man. You see, words are the same, but it takes for the system fraction of a second to understand who is chasing whom. So when we say we understand sentence, we also say that you know that because sentence is an event, and we know that somebody is acting some event, something is happening in the event. How do we determine that, right? Now, those of you who know English, you can easily say that, see, this is a fixed word order language, and you have a fixed position for subject and object, and maybe that is where from we are deriving. Otherwise, there is no changes, right? But so yeah, that could be that it is taking information from there. But then we know that the language of the world vary in so many respects, right? So how do language of the world actually behave in this way? Because our goal is to understand 7,000 languages we speak around the world. Biologically, we have one brain. So are there mechanisms which are independent of language, or language is something which is influencing? So there's some particular linguistic feature or some cues. So people there are several inferences which have been made, but there are certain things like that. Of course, so we know that certain things like case, word order, anyways, several linguistic factors are very, very helpful for the brain in determining to understand the sentence, that who is doing what. But yeah, the people have claimed that the cues may vary in some languages, like English, you can say word order. Some other languages, cues may vary. And we are asking questions like, so are there some universal mechanism that we can say that, okay, this is independent of language. Any language you processing is like this, right? Or typologically different languages are processed differently, or there are some features in some languages, some cues are differently. These are the kind of questions we are asking. And there are several models. If you're interested to have a better idea, there are several models, neurocognitive models available in the market, which talks about different aspects of how language comprehension takes place in real time. But as I said, like, I'll not get into the depth today. Where closely I am working on in this line of thought, you can say, is the field which has emerged recently is called NeuralTypology. That is combining the typological features and looking at the typological features, different typological features, and how it correlates with the function and the structure of the human brain. So let us say if I speak a different language typologically, that does it influence a different way or languages, which is known as, and this is something we do. And what we are also doing is actually, so come to like that, as we know in India, I don't know, like with the number, I should have been more careful, but we know we are speak so many languages in India. 4 and 5 families of spoken languages are there. We have done lots of work typologically and theoretically, but experimentally, if you see, there is not that much of data. So in our lab, exactly what we are doing is we are conducting experiments on various Indian languages, taking typologically similar and different languages and trying to test the cues that whether it is how much it is helpful for the parser, or it is like the way it helps, or one language is how similar or different to other in terms of cognitive processing, right? But however, today I'm not going to talk about the universal mechanism and other things. Rather, I'm going because the goal is to have a larger audience and understand, because those who are doing cognitive science also can get an idea that, or other area you are interested to understand brain, how we can use electrophysiological method to understand general mechanism of the brain. So today I'll highlight on this. The goal is like how we can use electrophysiological method. I will show you data, and I'm going to present one experiment on Hindi where I have manipulated animacy and agreement. Those who are from linguistics will know agreement is a well-known phenomena, but I will briefly introduce towards the end when I start presenting my topic. But before that, let us just have a walk and see what are the things and tools available in the market which is helpful to understand the brain. And I will also tell which kind of questions you can ask in somebody. And I will try to present as simple as possible. So as we know, like those of us who are from neurolinguistics background, we know that earlier our understanding about language and brain was completely determined and based on lesion-based studies. So when there was an impairment, then of course, as you know, Broca's and Wernicke's area, the patient died, and looking at the brain, we could determine that which part is functional and which part was involved as Broca's area, Wernicke's area. It was not possible to study normal population, normal brain. But today we are in a stage, we are studying children using different kind of neurocognitive methods. And of course, we have also trying to understand various processing related to language comprehension in the brain, how it happens, right? If I just introduce you, because there will be students also, so and those of you who want to take topics, please, you can ask me questions later also. So that these methods, we know that we have used, mostly we have used these offline methods in the history, if you see, to understand psycho-neurolinguistics or general cognitive science understanding, like questionnaire study. So where you ask the questions and people give your opinion and like that. Act-out studies and picture selection studies have been used a lot for in the research with children, child language acquisition, because you give tasks to children and tell them act out, and depending on how difficult it is for them to understand that task, we determine that this is difficult to process or easy to process. The one difference, major difference between offline and online method have been that offline method is that you determine things when the task has been completely completed. That is, means that we have processed already all the information. On the other hand, online method, like even reaction times, you can determine exactly at the point how much time it has taken to determine particular task when we are doing. And as we know, after 1950s, when we started getting access to good computers, there are so many tests which has been used in psychology and cognitive science, which we have used for reaction times. We got eye tracking, where we can do sophisticated. We also do eye tracking, but I'm not presenting this data today. So you can measure eye movements, and as you know, like people say that depending on our eye movements and eye measures, we can determine about the cognition, that how brain, perceive certain things. And generally, this is also extensively used method in the area of cognitive science in general. And now we have started getting more sophisticated tools like EEG, FMRI, where we have been using, and these are the neurocognitive methods. I'm just giving a glimpse of that. EEG, I will talk a bit more because that I am using. So you have electroencephalography, EEG, magnetoencephalography, MEG, functional magnetic resonance imaging. These have been used now with the normal population, extensively used. And why I'm keeping it simple is that still, if we start looking the data for Indian languages or India, it's not that much explored. So this is completely new. So EEG in general, and I'm going, after this slide, I will come to MEG, FMRI, then I come back to EEG again. So in EEG, we can record the real-time electrical activity of the brain. So we can record when somebody is performing some task, we can record the brain signals and try to analyze and see a particular time what happens in the brain. So this is very useful in the real-time understanding for incremental processing also. However, let us just have a glimpse of what people do with MEG. This is just for introduction. Here in the MEG, we can record the electrical activity, magnetic field of the brain, and also the temporal resolution. So it is also good to determine where question in the brain, and also like how much time it takes for the brain to do that. In fMRI, as most of us are familiar with MRI, but here we are not only interested in understanding the structure of the brain, we are interested to understand the function of the brain, how particular phenomena happen. But if some of us are interested in where question, a special question, where in brain, fMRI is extensively used to know that. The basic idea is that on the basis of the blood flow, that the part which will require more energy will have more blood flow. So when you are doing some particular task, then that area in the brain, and which you can see its spatial resolution is very good. In the millimeter, you can see that which part was active, and one can determine that, that this area was particularly more active when we were doing, we are doing certain tasks. So people are, and for language also, now there are various studies available where people have said, they have categorized that Broca's areas, there are multiple functions happens in the Broca's area, or where even syntax and semantics gets represented in the brain. There are various works available. But let us get back to our real questions of EEG. So in EEG, I'm going to talk about the 2 points. One is the EEG signals itself. There are different kinds of signals, EEG waves, which have been, as I showed, that Hansberger determined. And it is assumed that different kind of waves shows different kind of cognitive state of the mind. So in which kind of state we are, you can determine through this. I'll not get into detail. Let us see the function sometimes. So delta waves like deep sleep, theta, like sleep childhood, alpha awake. Most of the time you will keep hearing people that if you do meditation, alpha waves will improve or something like that. So this is anyway cognitive. Most of the time what we are studying is the beta waves. We have done some studies on the frequency based data, but today I'm not presenting that here. But yeah, there are a lot of things we can do just looking at the EEG signals. As we know, these are very important because when EEG signals are not there, we are dead, as we know. But these different kind of waves indicate different kind of cognitive process. And this has also been used extensively to understand, different tasks and different functions. However, what we do is mostly ERP. What is ERP? It is event-related brain potentials. That is, in very simple terms, we extract, because we are interested in understanding when we particular task is performed, how much time it takes for the brain to react to certain things, or how much information, time it is taking processing. So we are not looking at the complete EEG data, but we are only interested in looking at the exact point, at what point I have presented some sentence, some words, or some sounds, or anything. There are huge number of words available. So what we do is that we extract that. That's why you see this here, the event rate processor, positive and negative voltage fluctuation, the cognitive EEG, that is time locked to the stimulus. So it is completely time locked to the stimulus, that particularly, because I'm interested to see that what happens, and then we extract this from the ongoing EEG. I will show you the methods, but there are certain dimensions on which you can categorize this data. So here I will spend a bit of time for those of students who have not seen this earlier. So if you see this part, the right part of my right part where this graph is shown. So this you can imagine as a word or any picture you have seen. And then you see that P1, there are several peaks you will see. That is P1, N1. So P and N stands for negativity, N stands for negative, P stands for positive. And time means that after this much millisecond, we are able to see what is happening in the brain. Okay, so this has, for a long time, this has taken also that when information becomes available to the human brain. And these are the 4 dimensions on which we can categorize this data, that whether the effect is negative or positive. And those of, I should also tell here that please, the graph is slightly opposite. Generally, you are habituated to seeing of, because negativity is plotted upwards in this graph. This is just like that. There is nothing to do that. So you see the negative waves up and positive wave down. If you, those of you are good in graphs, so you'll know that. So, but this is just for convention, nothing to worry about that. Then we know the latency, that time point relative to the onset. So as I'm saying, anything you can do depending on the cognitive task you're interested in. But after the stimulus has been presented, after how much millisecond, what is actually happening. So you see P300 means there is a positive wave after 300 milliseconds, as simple as like that. Then amplitude of the strength, right? So how strong the effect is, like what is the power, and a skull topography, that which part of the brain you see the more pronounced effect. Yes. There is one more thing to keep in mind to see the result, that the ERP results are never absolute. That means that you have always a baseline condition and a critical condition. So the value when I'm saying something is negative, it is always in comparison to something. So it is not absolute completely. I'm saying this is negative or positive. So one line is correct one, let us say, for language, and the second one will be incorrect one. Then I'm comparing that. So I'll get back to that. This is just some pictures if you want to see that how they prepare the electrodes and how they are conducting the experiments, how we're analyzing. This is a glimpse of that in our lab we are just showing, and I will give a clear demo. So for students, you see that the participant is sitting with the EEG net and it's connected to amplifier. Then People are recording the signals here. So you see that, and this is a stimulus presentation software, the black one. So you're presenting from here and you are recording all the EEG signals. What you see in the data is like this. So you get something which I have shown you, the EEG data. And then we extract this method. I'm not talking. So there's a fixed procedure we use for pipeline filtering and all. And then we average across participants. And what you see after that stimulus is something like this, which I have already explained, that you will see negative, positive effect, something like this. And this is always one thing to keep in mind, will be good, that it is always in contrast to something, which I will show you now. Now, there are various kind of electrophysiological correlates which has been reported in the market, which has been shown to map with different kind of linguistic phenomena. So if you have a look here, so the earliest study on the semantic one. So here on this slide, what I am trying to tell is that different kind of components have been correlated with different kind of linguistic phenomena. However, today, this one-to-one mapping is a bit problematic, but as I said, I'm presenting in a very simple way. We'll see at some point, we'll see on that. Maybe there'll be an occasion, but here. So N400 you see, and this kind of sentences when they are presented. I think this point also I missed. So in this paradigm, this is not the only way to do it, but it has been a general way to use the violation paradigm. Violation paradigm means that we create some kind of ungrammatical structure in contrast to the grammatical structure. And if this ungrammaticality may be in semantic terms, semantically incorrect, or syntactically, morphosyntactically, and then see that whether the brain is using similar mechanism, or brain has a similar or different type of difficulties in integrating this kind of information. The first component which was reported, like he spared the warm bread with socks. So if you see that this sentence, instead of he spared the warm bread with cream, you see this. So and they reported this N400 effect. If you can see this picture. And they say that this kind of component you see when you have a semantic problem, integrating the semantic information. Those of you who are from linguistics, you will at least see that max of proof of the theorem violates the phrase structure violation, that you cannot have two prepositional phrases together. And this they reported to have early left anterior negativity, which is visible around 150 to 200 milliseconds. For quite some time, it has also been convention to show that which kind of information is accessible to the brain when. So it has been believed that syntactic information is accessible earlier in the semantic. But as I said, I'm not going in that line today. Then there is another component, LAN, which is somewhere similar to N400 in the time that it comes in the same time range, though topographically it varies. Remember the dimension I have presented. So there are different topography. It is most left anterior side. And then there is a P600. We have also seen P300, which has been reported for various kind of tasks like syntactic violation, semantic repair, reanalysis, and kind of things. So general, as I said, the disclaimer should be here that this one-to-one mapping I'm saying for different type of tasks now is being challenged, and there are various interpretations possible. But because I'm assuming that many audience are hearing this for the first time, so I'm going as simple as possible. But as you can see that we can correlate these things with different kind of linguistic tasks, right? With all this, I get to my question of agreement, and it will be a bit of linguistics. So those of you who are not the background is boring, I'll quickly jump to this, but this is important to have background. I have taken agreement and animacy. I'll get back to why I'm showing you this data, which because I think it is helping me to show you how electrophysiological findings can be really helpful to tell us about language comprehension system. But agreement, anybody from linguistics will know that it is well explored phenomena, both theoretically and in both psycho and neurolinguistics also people have worked a lot on this phenomenon. So if I am looking for universal strategy, this will be one of the important thing. And those of you are background, we have all done a school days definition of agreement, that, and we know that the subject and predicate or the verb has to agree in some features depending on languages. And also there are various kind of agreement, like person, number, gender, like in Hindi, within clause or within phrase also, like we know that, and various languages show various kind of features. But the point here is that this is well explored phenomenon, both psycho-neurolinguistics experimentally and theoretically, we already know that. In Hindi, it is agreement system is very rich. So it's important to do that. But let us also see that electrophysiologically what people have reported. One thing which has happened is people have reported different kinds of neurophysiological correlates for different kind of study. So in the Kutas and Hilliard 1983 work, they say some shells is even soft, instead of R, and they reported a LAN for this one, which I have shown you earlier. In some cases, people have reported LAN and positivity effect. Some cases only positivity effect. Different types of neurophysiological correlates, even for the same phenomenon. As I said, this one-to-one mapping is not working like that. There are some studies on Hindi, previous studies. One we have ourselves done it, as you see, 2011, and other studies, where they compare this Hindi data, and if you see this structure used by Nevins et al., they use the future tense, sorry for the brevity, I have not give the control condition. So here you have to imagine a correct condition instead of, and then these are the critical conditions. So they violated the agreement, different types, person, number, gender in Hindi, future tense. And they observed that for the C positivity, though they reported that person is stronger, as I have said, you can also determine this on amplitude basis. So person had a stronger amplitude than others, which they dedicated to the special status of person. But general mechanism, they said, is looks similar, that that it shows positivity, and person, number, and genders are not different in terms of how it is processed. We conducted one experiment, which is, the goal was different because we did it on long distance agreement, but we don't need to confuse ourselves right now. So we explored this kind of sentences where I used a sentence like Ram cycle chalani chahti hai instead of chalana chahta hai, and instead of Ram ne cycle chalani chaha. And if you see this left and right column, mine one, you see a negativity positivity pattern for this kind of sentences where you have agreement with Ram, and we observe only negativity pattern for a sentences like Ram ne cycle chalani chaha. So for this kind of violations. So we were wondering, of course, that what is happening, that even the same language, of course, we know that if you go, if I go into the agreement system on Hindi, then we know that it varies across tenses, and there are some complications to it, but still we will not believe that what could be the reason to have these neurophysiological differences in this domain. So it looks interesting, as I'm saying, from agreement point of view. However, there are other studies also like that they have explored it, like processing of, and various questions they have explored is whether person, number, gender are the same feature. If you are violating agreement on the dependency on the clausal level or the phrasal level, is it different or not? Or different types of argument, even subject and object agreement and like that. However, this green thing I'm always making, which I am doing today, and people have also tried to do this grammatical, looking at the grammatical and the natural gender. Grammatical, as you know, like some languages allows the gender for inanimate arguments, and natural genders are for the animates and more humans, animals, where the gender is more classified. And they have said that some ways the differences could also be depending on this one. So one slide on animacy and cognition, because animacy in general has been a very, very important thing for general in cognition research, because people have shown that animacy actually varies from child language acquisition, that children starts making distinction of animate versus inanimate arguments from very early stage, you know, and then people have reported different kind of neural activation pattern for animate versus inanimate. And for linguistic language comprehension also, it has been reported that it can be an important cue for language comprehension guiding the parsers. Those of us who know linguistic theories, we know that, you know, animates are suggested to be more prototypical actors, like it is more like agent. So it's more like, which has a volitionality, agentivity, than inanimate, which is believed to be more like an object argument or something like that. So looking at all these dimensions, what we thought to do an experiment, very, very simple experiment, I'm going to present to you from Hindi, where we have manipulated this, and I will tell you the reason we have done that. The idea was that one thing, of course, to explore an agreement, why we see differences in the same language. And animacy in general looks to be somewhere grounded in the brain, that people perceive it somewhere very differently than the animate one, which is not surprising if you see general, because, you know, as a human, we are more active, and that's why in the children research, language acquisition, it says because we are more moving and things like that, they start making distinction very stage of that. However, interesting in Hindi is, because Hindi, though I will quickly run through it, if you are not from linguistics that we like the Hindi agreement system, we know that the idea is in Hindi is that always when there is no marking of the case, like overt, ne, ko, say, what you know, then the verb will agree with that argument. And when you have this argument mark, that's why you have object agreement, right? So animacy has not been, of course, in this structure, you can say that it is decided on the animacy status, that it is agreeing on with Ram because there is no case marking. But in general, animacy has not been told to play any role in agreement system, at least in Hindi. So we used a very simple design. As I have said, it can be comprehensible for anybody. We used these 4 sentences, you know, for experiment. We used intransitive verbs like fall, okay, and we use a sentence and where we explored all the masculine arguments. So like boys and the fan, because in Hindi, as you know, book is feminine, fan is masculine, or this distinction is there. And we wanted to test, because of course the language is not explored that much, so that way it was simple, but we thought that this simple experiment can tell us a lot about cognition in one way, that whether the mechanism brain is adopting for computing this agreement property is same or different. Secondly, if animacy is really of fundamental differences, then does it make a difference in Hindi? Because in Hindi, we will not expect it to make a difference, because agreement system is such in Hindi syntactically that voice girta hai and pankha girta hai. It should have the same mechanism to adopt when the parser moves to process these kind of sentences. Actually, it should not make any differences in general. So we manipulated this. This was our control condition, like the ladka girta hai without ladka girti hai, and the pankha girta hai versus pankha girti hai. We manipulated this to test whether what it can tell us about the agreement pattern, whether it uses similar mechanism. And as I said, why I'm emphasizing on this point is that in general, our hypothesis is should not make a difference, because if the brain is taking nominative case marking, I can use a bit of linguistic word, nominative, that there is no case marking and it should agree with this one, then it should have the same processes for Y and the fan. And of course, we have used intransitive structure. So there is not much differences because this is a very simple structure possible, right? So as I said, our hypothesis and prediction was that in general, because in Hindi, the case marking is an important cue for processing, animacy distinction in these cases should not make much difference. However, if animacy is also stronger or it has some different behavior, then we must see a neurophysiological differences. Either we see N400 or P600, and we must see a difference in the waves. The behavioral data was like this. We saw clear-cut distinction between ungrammatical and grammatical sentences that people like say, okay, though for this one acceptability is a bit high, but still it was fine. This is the graph you can see. So these two really shows the following, but this is still a bit high for inanimate ungrammatical structure. Coming to the neurophysiological result, if you recall, if there are people who do not speak Hindi, then these are the sentences where I used boy falls, and for this an agreement in these cases showed a positivity effect for that is for the animate incorrect sentences, and a positivity effect in comparison to the correct condition where animate was correct and when animate we did, and we observed a positivity effect. But there is a surprise. When we saw with the inanimate arguments, this was completely a contradictory result. We did not see a positivity, but we saw a huge negativity effect. So if you have seen the graph, people can easily find out the red color is shows inanimate incorrect, like pankha girti hai sentences, and we observed a huge negativity. This is typically slightly different time windows than we see for N400 time windows. But nevertheless, and this suggested that actually something is different. We'll see to the result, but at least I think I want to convince that this was this is a surprise to us also, and we are trying to understand what could be the possible reasons. But we did not see the same pattern for the animate and inanimate agreement processing in Hindi, right? So let us try to see a bit of result and what we think about that, and then yeah. So we observed different results for animate and inanimate arguments. Animate showed P600 and inanimate showed N400. So simply I can conclude by saying that yes, these two things shows a different kind of behavior, and it looks that mechanism is different. But question remains that why it will use a different mechanism. Now there are many options to explore. As I said, that it is because of the status of animacy, or in Hindi also animacy is really distinct for any phenomena, not only agreement and like that, because in these cases we heard that it should not make a difference. But let us see some results, how we can interpret it. In some languages where people have really explored animate inanimate distinction on agreement, they have showed that it is like N400, P600, LAN P7 and P600 for animate, which somehow is similar to our results also. And then this P600 and LAN P600, and you see there is no symmetry here also. So I'm going to talk what are the possible things I feel that could answer some of these questions, and I will also look forward to suggestions from people so that it will be helpful for us to understand that. So animate is showing P600, inanimate is showing N400 results. Now there are various kind of interpretations people have given in the market, like gender as a part of syntax. So you see P600 effects, integration issues, or syntactic processing, reanalysis difficulties. So these are related to processes. Sorry, I have not introduced these terms earlier, but basic idea is that the brain has to do something for different, but there are multiple interpretation possible P600. But same thing is for N400, that people say that mismatch of conceptual information, sentence wrap-up effect, semantic processes, or gender retrieval to Lexus integration problem. There are various others in the market available. Though I think that it is difficult for me to interpret completely in these lines, but I will give some input on what we have been thinking. Earlier effects, what we have presented somewhere is, and some published work, we have said that P600 we have interpreted in terms of well-formedness structure. Basic idea has been that when structures are not well formed, we see this is for well-formedness check. And we have also reported for aspect case violation, there is N400 effect, which we said is for rule mismatched. And earlier that gender studies I have shown you earlier, we said that it is because of the gender mismatch. But this gender mismatch phenomena is similar in the sense that with animate and inanimate. However, of course, inanimate has a grammatical gender, and one can say, okay, that is different, and N400 is showing that kind of behavior. But anyway, so these two interpretations also we have taken formally, but here we'll see that. So earlier also, so of course, so one idea is that of course this looks different, but I'm now going to highlight on some of the possible speculative answers which I think could be possible. And so P600 we have said is that it is for well-formedness. Then question comes that why inanimate ones are not showing this kind of behavior. Does people think that these sentences are okay, and then it is okay, then why this N400 is reflected, right? So one thing which is clear, and I'm going to interpret two things, and then I'm going to correlate this data with general cognition. And so idea is that after seeing neurophysiological differences also, we have interpreted earlier and said that P600 is disappearing in Hindi when you have the options of more variations. And that I mean by the dialectal variances. As we know that Hindi has options, I mean, there are several dialects, and there's certain things like which vary according to. So what I expect is with inanimates, as you know, like I have not done this study, but it's a speculative answer. Answer. So I'll also be happy to get some input on it. But the idea is that with inanimates, you will see variations. That in some cases, in some dialect, you will see people using both kind of masculine and feminine, because it's not that clear as with the case of animate. So when you say boy, ladka girti hai, you don't seem to be having a dialect where people will find it okay. But at the same time, when you say pankha girti hai, you do find people saying okay. Like in a there is like place in restaurants also we used to say that bus chalti hai, bus chalta hai, both kind of sentences you keep hearing from different dialects. And one of the possibility looks like that it could be, and this is about the positivity. So we have seen that. I'll get back to this again, but more variations. What we are saying, one thing we have been saying is that maybe when there are more variations, then positivity is disappearing, at least for our languages. Why I'm saying that, I'll come again to this one. And this is the reason. So agreement with animate argument seems to be uniform. There is no variations, and we just see that, and one more slide is there. Well, I'll make clear answer, but yeah, so it is more uniform across participants. However, when it is with inanimates, it is not that. Further, animate arguments are more like an agent arguments, actor arguments. As I have said in the very beginning, animacy distinction is very clear that way. And is it possible that, again, I'm raising this question, I don't have answer, that actually the parser is looking for more agent-like argument to agree with the verb rather than. With this distinction, people have not talked theoretically, but we are just speculating that is it possible that parser is looking for more agent-like argument to agree with, and not the inanimate one, which is more object-like, or which is not prototypical actor. And maybe the distinction lies there, the way these animate and inanimate arguments are perceived by the parser. Some accounts of this has been, like now the interpretation of P600 and 400, the way people have given, is in terms of decision certainty. So here I will go back to cognition, and then 1 or 2 slides, and then I'll be done and to call the answer. So as I said, I'll get back to this cognition and also information processing. So somewhere people have started taking that P600 not as a completely language related component, but it shows a general cognitive behavior. That is, when we are certain of some decision, then it shows a positivity. So is it possible that this positivity we see because the parser is more certain in the case of animate argument, that okay, there's animate argument, so this kind of agreement has to be there. But in the case of inanimate, this is not the case. So we do not see positivity, and we see only positivity here. Other option is that N400, and people have said also there is a competition for the actor roles. When inanimate is competing for the actor role, because then it could be that also somewhere it is interpreted like that. As I said, one possible answer could be that it is like competing also. So when it is processing inanimate arguments, there is something else happening. That the verb is looking for some kind of more agentive argument, and when this is an inanimate argument, then find it prototypical done, and then there is also mismatch of agreement. So there is more complexity, and we see an N400 effect. Right. So these are the possible answers to these questions. So coming to this conclusion and future directions. So as I said, like the goal of today's talk was to see and show that how electrophysiological data can give us very, very fine, clear distinction to understand language comprehension. I think that with other methods, it would have been very difficult to understand this kind of phenomena. And this looks to be like with simple intransitive sentences, as I have shown you, that it looks that, I mean, there is a clear distinction. Theoretically, as I said, we are not claiming any distinction because, but experimentally, we seem to be showing that there is a difference, right? So we can get this from electrophysiological data. And what it gives for more consequences for in general for language comprehension and cognition in general. It also says that case, for this study I'm talking, not in general, that case we have seen always more as a prominent cue in Hindi like languages. But however, it says that animacy is also very important, and I think it needs to be explored, particularly for language comprehension. Now, this is an idea. Is it only for language, or is it a general cognition distinction of animate or inanimate argument, the way we perceive the world with animate or inanimate? That is actually making an impact. That has to be, again, explored. So we'll have to see how this data can really correlate with the general cognitive science and functioning of the brain, right? But yes, what I would like to tell is that, of course, I hope that I've been able to tell that we need to explore more typologically different languages to explore it. And we need to do more collaborative work, right? More electrophysiological work. And collaborative, when I say that for cognitive science as it is emerging and people are not coming from different backgrounds together to work on. So people from psychology and different branches, hopefully some people are hearing me the way it was planned. So because it takes, because language, one of the difficulty in language and cognition is that we need expertise from different fields to understand this. So it's not possible with one person. And generally, if you are trying to understand the brain functions and these ones, so it is helpful. But so general collaborative work from different fields within the field, of course, and more electrophysiological work on language and other cognitive systems. The more we can understand, it is very important to have it. And then, of course, my general goal is maybe some other time I can talk at that. Some data I want to talk on that. But as I said, this was planned to be introductory and collaborative in nature. Then the idea was that, sorry. So the idea is like, is it like language? So the one question, as I said, I'm not answering today, but we are seeing that is it like some aspect of language, the way it is processed is actually not only about the language, but it is about the functioning of the brain. That when something decision making or prediction is sure that it is behaving in some way. And the one of the questions we asked on the very first slide, that how far language as a system is similar to other system, is also that is possible to get from this kind of data. For that, we have to, and of course we can understand, so how far it connects with other part of, so this brings us to the cognition part, how it connects to the other part, like general functioning of the human brain. So something like if we take prediction or decision making, it is not a property of language, but as you see, if I'm saying that in certain cases, decision is certain or prediction is certain, then it is behaving. But prediction, as we know, is a general cognitive thing which we have. So how language fits to these things. So maybe we can talk at some other point of this. This is the website, and these are the things we are doing. Some students you are seeing, they are helping you always the slides and work they are doing. So thanks to them, and thank you for your attention. And these are the differences. And yeah, so I'll leave it here, and I'll be happy to get questions and talk more. Yeah, thank you.
Thank you very much, sir, for your interesting and very deeply explained talk. So session is open for question answers. So I would request to all the attendees, if you have any questions, please write in a Q&A box. So it would be easier for us to ask to speaker, and he would be happy to answer all the questions. Meanwhile, I would request Professor Singh to, give remark on the lectures.
Yeah, thank you, Dr. Gulabchand. Some people have started writing in the chat box, so you have to look at both boxes. Okay. One of the interesting thing, Dr. Chaudhary, one of the questions that has come from Arul Moi is that what is the size of your data? What is the size of your informant? So if you can tell them, then perhaps that is something which is
yes,
clearer.
yes. So we have taken around 44 participants. So I didn't present it to save time. I didn't give more detail on the how a stimulus was presented and how participants we have taken. But yeah, that is a good question. So we have taken around 24 participants. We have 20 to 24 participants we have taken in this experiment. And that is a standard,
Okay.
like of course we should take more. Yeah, yes, sir.
Yeah, my query is much simpler. It looks simpler, but it may not be so simple. That is, Hindi has a typical decision-making procedure vis-a-vis agreement system. When you have a new word entering into Hindi, supposing there's a new animal which has been discovered, which was not known to the world as such, an animal which comes from the fiction, comes from the film, comes from imagination, comes from mythology or wherever it is, a new animal which is introduced into Hindi sentence structure. Now Hindi has to decide where to place it, in the masculine box or in the feminine box. If that kind of situation comes, because when you say that agreement with animate argument is uniform, what happens when a new animal is introduced, a new name is introduced?
Yeah. So actually, yeah, I think as you already said that you knew it, that it is complicated. You made said that it is simple, but yeah, the idea is this is a very interesting question, and in general, not only for so this part we have been working a bit, and not only for new entry words, of course, but general also it looks like for inanimates, it's very difficult to determine the strategy how we have assigned gender. This is a very, very difficult question. We have tried to look for some research. Maybe you can suggest something. And this looks to be a bit like arbitrary. That's what we are saying, that in some cases, some rules are there like e-marking will be feminine, this, that. But with inanimates, we have always found it very difficult. So I am not sure on like how we'll treat that. But even in the existing one, I think there is a difficulty. And that is what I'm saying. So see if I can say on, I don't know in this platform, but one of the things we have been telling is that, and some kind of neurophysiological data is coming now, where people are saying that certain things can be a indication of language change. So it could be that with inanimates uncertainty, that at some point, maybe some years down towards, I cannot picture it like that, that agreement will disappear with inanimates in Hindi or languages like that.
Okay, that's a possibility. That's a good possibility.
That is one possibility.
There is another thing that you may like to think, you and your students may like to think. When you have two languages like French and Hindi, both having grammatical genders, then try and find out some parallel sentences and parallel possible mistakes and possible misinterpretations, and then process them and see what happens. Yes. With the French native speakers, what happens yes. with the Hindi native speakers, yeah. And then bring in a different kind of typology. Yeah. So that is something which perhaps could be important.
Yes, sir.
The other point that I had was that when you have an explanations like well-formedness of construction, and you are correlating it with the P600 result, now, is it your interpretation, your speculation, or anybody else in your position who would be doing electrophysiology of language would have come up with the same conclusion? This is another point that I thought I will ask you.
Yes, sir. No, this is very good, sir. So as I gave, I showed on some slides, there are multiple. So P600 has been now correlated with different kind of interpretation. So some people say it is a reanalysis process, like when you are reanalyzing the structure. So basic idea is that when ungrammatical structure is encountered, the parser is reanalyzing the structure, or there's a repair process. There are various interpretations possible. As you have seen some cases, I showed the syntax one. So everybody will not give the same interpretation. This is Bonkas and Slezowski, they have given it for P600. And the kind of a structure we have used, I feel that this explains it better. So well, but yeah, when in P600 case, as I said, and this can be correlated with different kind of results also. It is possible, the way people are interpreted. The other interpretation are also possible of P600. But yeah, my thing which I have been trying to tell is that in some other cases where we have not seen P600, and where we are like in this case of this inanimate structure, where it is disappearing, which I am trying to tell is that it is happening because of the let it go kind of attitude. So when we are incorporating inanimate with violation, agreement violation, people might have, because we have a tendency. So what actually I have been trying to tell you that people have a tendency to hear some kind of a structure. And when they are like that, and even if I am the native speaker, I do not use it myself, because of the exposure to such kind of structure, sometimes I'm not worried about the well-formatedness of the structure. This is something what I'm telling. But P600 has multiple interpretations. So in the case of inanimate, grammatical error is detected, and I have seen this in the case of case also when we have manipulated. However, as you know, which will not happen in the case of animate. So disappearance can be accounted by maybe that people are thinking that it is like kind of okay in general world paradigm, they are finding it kind of okay. So that is the kind of interpretation we have been thinking for quite some time.
Okay, Rajiv Chakrabarti has a question. He says that more than the number of participants, the linguistic competence of
the subject should have more impact on the results. If some light is shed on this issue, that would be nice.
Yes. So
should I repeat the question again?
I can also see the questions.
More than number of participants, the linguistic competence of the subject should have some impact on the results. If some light is shed on this issue, that would be nice.
Yes. So I think, see, these are, so as I
should have been have a
hello. Hello.
I think he might be having some some.
Okay, so till sir comes back, I'll try to answer some good questions. Yes. So this is a very important question, and thank you for that. Yeah. Oh, sorry. Yeah. Sorry, you are saying something. Yeah.
No, he was asking the same question.
Okay.
Rajiv Chakrabarti.
Okay. So I think this yes, this is very a good question, and so as I said, like I have tried in today, I was trying to be as simple, and that's why and to maintain the time, I did not talk a bit more about the participant information and all kind of things. But this is a big issue because of the bilingualism we have in the country and the proficiency of the language. This is something to look up. I do not have exact answer on that because it's very difficult. So the parameter we set for taking participant is that we say that they acquired Hindi as a first language, something like that. So states we have taken is like Delhi, MP, you know, and we try to in the questionnaire, or at least even 5 years of age, where we really see that it was acquired, it has not been learned in the latter age. So these are the parameters we are taking. But yes, this is a very important question, but difficult to answer and test. But these are the things we need to do, like bilingualism, proficiency, impact of age, because all these questions are coming up. But I have not looked at it. I believe that those participants who have participated on these parameters, they have, it is their mother tongue. That is like that. But yes, this is something we are really looking for: the proficiency, how it impacts, and even the age of acquisition. These questions are very much there. So it's a very good question, but maybe in future we'll have some answer. We can try to do something. Because see, one thing as I have tried to tell is, and I have been so simple, I didn't get into much detail, that you start searching on Google and you see how many studies you get on Indian languages on this project. So we have not started that much. So we have slowly trying to take some languages and do preliminary studies. And of course, now cognitive science departments, neuroscience departments are coming up. So people have started other cognitive process. This also, like bilingualism is now there. Like in my very introductory talk to engineering students, I was telling last time that for impairment cases, we don't have even the battery test. How will you test aphasia or dyslexia in languages? We don't know that. So we have a parameter test like that. So these are the things, like even testing proficiency, how I will test for different languages. So on root level, there are various issues which has to be taken. So I mean, research-wise, there is a good life for those who want to do this, but it's difficult because we do not have that much. I think this question is also relevant here, because in impairment case, which I have not touched, like, you know, we do not have battery to test how you test impairment. Like proficiency, how you are testing. So we are saying that, okay, I'm testing. Some people have started doing that. So on the very basic level also, things are required. But this is very good question, and I think this has to be taken, because we cannot determine certain things. Because my problem is, how do I determine that, okay, how is the person proficient in that language? What battery I will test with? What question I will ask? So even these things are not that much streamlined for Indian languages, right? And I'm sure, sir, I mean, this is a very good opportunity for me to present it before Professor Singh, because he knows the linguistic world in India so well that he can even suggest us for future that how these things can be taken up, so that we can, because I have talked to some people, because now NLP research is happening so much, so we can take that, or develop some kind of battery for impairment and normal proficiency test also, because this is not even, I don't think that even available for several languages. So we have much challenges on that. So sorry, I'm taking more time, but this issue is such that I thought I'll spend some minutes. Yeah. More than number of the participants. That was highly interesting and informative session. I'm hoping if this can also be linked to visual arts, which might lead to a different venture combining language, cognition, science, and ways of seeing it. Yes, yes, of course. As I said, my goal of talk, you see, if I would have spoken general on cognition or something, I would have taken that. So my goal was to show some data because it was language comprehension I was just speaking. But towards the end also, and the beginning, I concluded it that we have to see from other cognitive point of view. And that's why I was trying to link it to decision other making. So yes, and there's so much work happening on different aspects of perception, thinking, attention, and how it links to language. So this is a very important point. And of course, only thing I'm suggesting here is that we need to work more. That is my conclusion. And only thing I was trying to show through this talk is that hopefully it shows that how informative this electrophysiological data can. More than that, I'm not giving any answer to any question today at least.
Yeah, that's true.
Yeah.
Okay, Dr. Gulabchand, I think you can now give vote of thanks.
Sir. I would request Professor Yuan Singh to propose vote of thanks to a speaker.
Yeah, I'm so grateful, Kamal, that you have come in and you have raised the hornet's nest, because I'm sure those who have been listening to you, both from a linguistics background and from literature, language teaching, and other backgrounds, everybody must have got very excited that there are a lot of possibilities of working in this area. And this is something where I will not say that exactitude is a typical quality of linguistics, because in linguistics, nobody wants to be exact. Nobody wants to, no explanation is there for which one can claim that this is 100% true. This is a possibility. It's a science of possibility.
Yes.
I think that's the way, if you look at it, then perhaps the language and cognition, particularly cognitive linguistics, makes this much more visible, much more important. And in that way, I would say that you've done a great justice by presenting non-technically, as much non-technically as possible. This is not really a non-technical subject. This is a very technical subject, but you've still made it as much non-technical as possible for the larger audience, and that is something which is great. And I'm sure after this, several people from Amity or elsewhere may like to write to you and send you their ideas, and we could surely collaborate with you and come up with some kind of interesting presentations, interesting papers, and interesting explanations vis-a-vis Indian languages, because Indian language data is so enormous and so huge and so full of possibilities, explanations. Particularly in case of agreement that you mentioned, I have a whole theory of verb agreement hierarchy, universal hierarchy. I worked on about 99 different languages of the world and come up with some data. So many of those can be married to this kind of work. So thank you very much for today's presentation. And thank you, Dr. Gulab.
Thank you very much, Professor Yuan Singh, and thank you very much, Dr. Kamal.
Can I thank?
Yeah.
So thank you, sir, and thank you, Gulab, and for organizing this. I would also like to thank all the people who attended this. Those who could not attend, if you write it, that was the goal, sir. And so to have it, so thanks a lot, and that's what I'm looking for. And as I said, that more, because we need, it is not one person's job, and also to aid, like this also gives chance to collaborate with other people who are doing computer science, engineering, and like that. Sure. So I'm really thankful that, and that is what I'm trying. And one thing, sir, I would like to tell you, this is very interesting. We'll look at it. This is what we are doing, like agreement hierarchy and this like animacy hierarchy. Like as you rightly said, that I was trying to avoid as much as possible. So on animacy, I would have talked like animacy hierarchy, then agreement hierarchy, and how it could. These are the things actually we are interested in, to see that how it maps with, because I'm a linguist and cognitive scientist, so I'm trying to look at how these features actually map and these theories mapping. So I'm also looking forward to it. So thank you all for such a nice time and listening to me, and thanks to the audience. Yeah,
thank you very much, sir. Thank you, sir.